So let's get started on the 2019 Key Stage 2 SATs Maths Paper 2 Reasoning. Starting with question 1. In this grid there are 4 multiplications. Write the 3 missing numbers. So we've got a missing number here, here and here. If you know your times table facts, this should be quite a straightforward question. If not, you're going to have to count up in multiples. So the first one, 4 multiplied by 8 equals something. So you can either count up in 4s or you can count up in 8s. So 4, 8, 12, 16, 20, 24, 28, 32. Then we're going to do this one down here. 4 multiplied by 3. Again, you can count up in multiples of 4 or multiples of 3. So for this one, let's go in 3s. 3, 6, 9, 12. And if we did do it in 4s, 4, 8, 12. Now the missing number in the middle is part of 2 calculations. We've got 3 times something equals 21 and 8 times something equals 56. If you are confident with recalling multiplication facts, you will be able to see straight away that it is 7. If you don't know your times table facts, what you would need to do is either count up in 3s till you get to 21 and you would realise that is 7 times, or count up in 8s until you reach 56. Looking at question 2, it says what number is 1000 less than 9072? So for this we've got to think about our place value. So it's a 4-digit number, so we've got thousands, hundreds, tens and ones, and our number is 9072. It's asking me what number is 1000 less. So for that, I'm only needing to take away 1 from the thousands column. I'm not taking away any hundreds, tens or ones. So these are going to remain the same. And my 9000 will become 8000. So my answer here is 8072. Question 3. Order the numbers starting with the largest. Match each number with its order. So we've got 4 numbers here, all with 7 digits, so they're all into the millions. And then we've got the order from largest to smallest, and we've got to match them up correctly. So once again, we're going to be thinking about place value. And because they are 7-digit numbers, our column furthest to the left is the millions column. Then we've got the 100,000s. Then we've got the 10,000s. Then the thousands column. Then hundreds, tens and ones. When we are deciding which numbers are largest or smallest, we're going to start all the way over on the left hand side. We're going to start by looking at the millions column. Well, as we can see, they have all got 1 million. So we need to move over to the column next door, the 100,000s column. So that's got 0 in the 100,000s, 0, 0. But this final number here has got 2 in the 100,000s. So that means that number is larger than the others. So this can be matched up straight away to the largest. Next, we're going to need to look over in the 10,000s column. And we've got these 3 remaining numbers to look at. So we've got 0 in the 10,000s, 2 in the 10,000s and 0. So again, this is the number that is larger than the other 2 because it has 2 in the 10,000s column. So I can match that up. Next we're going to need to look at the thousands. So we have a look, we've got 9,000 and we've got 9,000. So they've both got the same amount, the same value in the thousands column. So we move across to the hundreds. In the first number here we've got 900 and down here we have got 0 in the hundreds column. So this one is larger. And then finally the remaining number is the smallest. Question 4. Here is a shaded shape on a grid. Reflect the shape in the mirror line and use a ruler. So we can use the squares on the grid to help us to do this correctly. So I'm going to choose a corner to start with, and we can see that that bottom corner there is 1 square away from the mirror line. So on the other side, I'm going to count 1 square away, and I'm going to mark where my corner will be. If I come back to the original shape, I go across 3 squares horizontally. So on the other side, in my reflection, I'm also going to go 3 squares away from the mirror line. So I'm going to use my ruler, line it up with the lines on the grid, and I'm going to draw 1, 2, 3 squares. So going back to the original shape, I'm now up to this corner. Now we need to go vertically upwards, 1, 2, 3, 4, 5 squares. So I'm going to start with this corner over here, and once again I'm going to line my ruler up, and I'm going to go up 5 squares. 1, 2, 3, 4, 5. So I'm up to here now. Then we go back towards the mirror line, 1, 2 squares. So lining it up, back towards the mirror line, 1, 2 squares. Now it gets a little bit more tricky because, as we can see, the remaining 2 lines on this shape do not follow the lines of the grid. They are diagonal lines. So what we're going to do here is we're going to look at this point where these 2 diagonal lines meet. That point there is 3 squares away from the mirror line. So staying on that same line, I'm going to count 3 squares on the opposite side. 1, 2, 3. I'm going to mark that down. And that should be the point where my 2 diagonal lines meet. Question 5. The numbers in this sequence increase by 45 each time. So we can see increase is in bold, and that means the number is getting larger each time. So we are adding 45. So from each number to the next number, we are adding 45. So 155, add 45 will make 200. 200, add 45 will make 245. Then we add another 45, that will give us our missing number, and another 45 will give us our next missing number. So for sequences like this, I usually start with the numbers at the end of the sequence, as we've already got our starting numbers provided for us. So I would need to do 245, add 45 to figure out what is missing here. Now you can do this mentally, because I know that 45 add 45 makes 90. However, if you're not confident to do this mentally, you can use column addition. So 245, add another 45. 5 add 5 is 10, 4 add 4 is 8, plus the 1 is 9, and then 2 in the hundreds column, 290. Then to find the final number in the sequence, we have to add 45 again. So we can do 290, add 45. Can do this mentally by thinking, right, we need another 10 to get to 300. Then that will only leave 35 to be added on to make 335. But again, just like before, if you want to double check this, you can use column addition. 290, add 45, starting with the ones column. 0 add 5, 5, 9 add 4, 13, carry the 1 underneath, 2 plus the 1 makes 3 in the hundreds column. Now, we are still left with this missing number at the beginning of the sequence, and we don't know what came before it, so we can't use add 45. What we can do is we know the number that comes after it, so we can use the inverse operation. The opposite of addition is subtraction. So we can subtract 45 here to figure out what comes before. Now we can do this mentally. 55 take away 45 is 10. So that would be 110. And to work this out using a written method, use column subtraction. 155 take away 45. With the ones column, 5 take away 5 is 0, 5 take away 4 is 1, and 1 in the hundreds column. So we've completed our sequence. For question 6, write the missing number to make this division correct. So we're starting with 0.3. We're dividing by something, and our answer is 0.03. So we can see that the actual digits are the same, but the place value of the 3 has changed. It's no longer in the tenths column, it has moved over to the hundredths column. Because when we think about our place value, so we would have hundreds, tens, ones, then we have our decimal point. After the decimal point, we have tenths. I'm going to represent that with a lowercase t. And then we have hundredths. So we have started with 0.3. So that's 0 in the ones column and 3 in the tenths column. Our answer has 3 hundredths. So we can see that the digit has moved across to the right one space. That means that we have divided by 10. The number has got 10 times smaller. So we have divided by 10. And the key thing to remember here is that when we divide by 10, all the digits move across one column to the right because they are getting smaller. So when the digits move to the right one place, we're dividing by 10. If you were to divide by 100, they would move to the right 2 places. And if you were to times by 10, they're getting larger, 10 times bigger, so they would move one place to the left. And if you were multiplying by 100, they're getting 100 times bigger, which is the same as multiplying by 10 and multiplying by 10 again. So they would move 2 places to the left. Question 7. Jack pours some dark paint into a container. In litres, how much paint is in the container? So we can't see the markings below the liquid line. We can only see the markings above. So what we need to do is figure out what each marking is worth. So I've got my litres, 3 litres, 4 litres, 5 litres. So I know that this marking that is exactly halfway between 4 litres and 5 litres would be 4.5, and between 3 and 4 would be 3.5. And that is only 1, 2 marks below 5 litres, and again 2 markings below 4 litres, we get to 3.5. So that means 2 markings below 3 litres, we should have 2.5 litres. Question 8. In this sequence, the rule to get the next number is multiply by 2 and then add 3. Write the missing numbers. So we've got a number missing at the beginning and a number missing at the end. Once again, I'm going to start with the end number. This is very similar to a question we did previously, except this time we've got 2 steps. So to get from one number to the next, we need to multiply by 2 and then add 3. To get from 25 to 53, we multiply by 2 to make 50 and then add 3 to get to 53. So to get from 53 to the next number, we multiply by 2 and add 3. So 53 multiplied by 2 is the same as double 53. And we can break this up, so double 50 makes 100, double 3 is 6. So altogether that's 106. That was just step 1. Second step is to add 3, so 106 add 3 will give us 109. To work out the number that comes at the beginning of this sequence, we're going to have to use the next number, 25, and work backwards. So when we're working backwards, we want to use the inverse operation. The inverse of add 3 would be to subtract 3, and the inverse of multiplying by 2 is to divide by 2. So we're going to do 25 take away 3, which gives us 22, and then 22 divided by 2 gives us 11. Moving on to question 9. Jack chose a number. He multiplied the number by 7, then he added 85. His answer was 953. What number did Jack choose? And we've got space here to do some working out. So we don't know what Jack's number was, so that's a missing number. We know that he multiplied it by 7, then he added 85, and his answer was 953. So just like the sequences questions, we don't know the starting number, so we're going to have to use the inverse operation to find out. So we're going to have to start with our answer, 953. And instead of adding 85, because we're working backwards, we're going to do the opposite, so we're going to subtract 85. Start with the ones column. We can't do 3 take away 5, so we're going to exchange. We're going to go next door to the tens column, exchange a 10 there, so it leaves them with only 4 tens, and give it to the ones column. So now we've got 13 take away 5, which is 8. We go to the tens column, we've now got 4 subtract 8, which again we can't do, so we go next door to the hundreds column, exchange 100, so they've only got 800s left, and give it to the tens column. Now we've got 14 subtract 8, which is 6, and then 8 in the hundreds column. So we've done the first step, 953 subtract 85. Now instead of multiplying by 7, because we're going backwards, we are going to do the inverse, which is to divide by 7. So we're going to do 868 divided by 7. And for this, I'm going to use the bus stop method of division. So we put 868 inside the bus stop. We're dividing by 7. How many 7s go into 8? Well, I can only fit 1 7 with 1 remainder. Then we think about how many 7s go into 16. If I count in 7s, 7, 14. So that fits only 2. 15, 16, so a remainder of 2. And how many 7s go into 28? 7, 14, 21, 28. So that would be 4. So our starting number would be 124. Number 10. A theme park sells tickets online. Each ticket costs £24. There is a £3 charge for buying tickets. Which of these shows how to calculate the total cost in pounds? And then we've got 4 options and it tells us to tick 1. So let's go back to the question. A theme park sells tickets online. Each ticket costs £24. So that's going to be each person, however many people go. So for example, if there were 3 people, each person's ticket would be £24. So to work out that cost, we're going to have to do the number of people, or the number of tickets, multiplied by 24. Well, I can only see one option that is showing me the number of tickets multiplied by 24. So we think it's this one. Then it says there is a £3 charge for buying tickets. So that means that we get charged £3 at the end. So we multiply the number of tickets by 24 and then we add on the £3 charge. So that still works out that it would be this option. So the number of tickets multiplied by 24 to give us the price of the tickets, then we add the £3 charge. Question 11. Amina is shopping. She says, I would like to buy 1/4 of a kilogram of cheese. Write 1/4 on the scales as a decimal. She buys 1/4 of a kilogram. So So that is what we are working out. 1/4 of 1 kilogram. 1,000 grams is equal to 1 kilogram. So if I want to find a quarter, I'm going to need to divide by 4. So 1,000 divided by 4. How many 4s in 1? That's none. So I look at the next digit. How many 4s in 10? 4, 8. So that goes twice. 9, 10 with a remainder of 2. How many 4s in 20? 4, 8, 12, 16, 20. That is 5. And how many 4s in 0? 0. So 1/4 of a kilogram is 250 grams. But we need to write this in kilograms. So that is 0 kilograms because we need 1,000 to make 1 kilogram. So it's going to be 0 kilograms with 250 grams left over. So 0.25. We could add the 0, but it doesn't make a difference whatsoever. So the answer is 0.25 kilograms. The key thing to remember here is that 1/4 is equal to 0.25. That is a key fact to remember. The second part of the question states that the cheese costs £1.35. Amina pays with a £2 coin. How much change should Amina get? We can do this mentally, or we can do it using a written method. First, to do this mentally, I would like you to imagine a number line in your head. And we want to find the difference between £1.35, the lower amount, and £2. To do this, we're going to count up. So to start with, I'm going to add 5p, just to make it up to £1.40. Then I want to get from £1.40 to £2, so I could go in jumps of 10. £1.50, £1.60, £1.70, £1.80, £1.90, £2. So 6 jumps of 10 pence, so that's 60 pence in total. So if we look at the difference between £1.35 and £2, the total difference is 65p. We can use a written method to work this out as well. And to do that, we'd use column subtraction. And we'd start with the larger amount on top, £2, 0 pence. Take away £1.35. It is important that you get your columns lined up correctly with the decimal points on top of each other. We start with this column over here, 0 take away 5, we can't do. We go to the next column, they've also got 0, so we go to the next column. They've got 2, we exchange, leaving them with 1, give it to this column. Now they've got 10, we can exchange again, leaving 9 and giving 1 over here. Now we can do 10 take away 5, which is 5, 9 take away 3, which is 6, and 1 take away 1 is 0. £0.65 is the same as 65 pence. Question 12. Here are 3 symbols. We've got less than, greater than, and equals. And it says write one symbol in each box to make the statements correct. I want you to think of less than and greater than as crocodiles. So I've added in the teeth, and crocodiles are always going to want to eat the larger number. They always want the most to eat. So the open side of the mouth is always going to be pointing towards the larger number. So in this case, whatever number is here, so 2, is less than 10. And 10 is greater than 4. So as we can see, with less than and greater than, the open mouth of the crocodile is always pointing towards the larger number. So we've got to figure out which of these is larger and which is smaller. So 7/10, let's think about our place value again. We'd have hundreds, tens and ones, followed by the decimal point, then tenths, hundredths, then we'd have thousandths. So in 7/10, we've got 0 ones and we've got 7 in the tenths column. So 0.7 or 0.07. So in this case, 0.7 is larger as it has 7/10. This has 0 in the tenths column. So 7/10 is larger, 7/10 is greater than 0.07. Then for the next one, we're going to continue thinking about a place value. This time we've got 23 thousandths. So again, we've got 0 ones, we've got 0 tenths, but we've got 23 thousandths, so that's the same as 2 hundredths and 3 thousandths. So 0.023. Whereas over here, we've got 0.23. So as you can see, the digits are 10 times larger over here. So in this box, we're going to have to put 23 thousandths is less than 0.23. So question 13 says, here is a sketch of a triangle. It is not drawn to scale. Draw the full size triangle accurately below. Use an angle measurer or a protractor and a ruler. One line has been drawn for you. So at the bottom of the page we can see that the line has been drawn for us already, and that is 8 centimetres. So to measure the line, we're going to put the very start of the line by the very start of the centimetres measure, and we can see that actually this line is only 7.4 centimetres, so that must have reduced in size as I printed it. So to start with, the first thing I'm going to do is just extend that line to the 8 centimetre mark, as we do want to draw this triangle accurately. So looking back at the original sketch, it says that this angle on the left needs to be 35 degrees. So that's where I'm going to start with mine. So we're going to use the protractor. This line here at the bottom intersects with a vertical line there. So I'm going to place this cross here on the end of the line where we want the angle to be. We need to make sure that that line on the protractor is exactly over the line that we're using. And then we're going to start from 0 and we're going to count up to 35, and we're going to mark the 35 degree angle. So start at 0, 10 degrees, 20 degrees, 30 degrees. So I want exactly in between 30 and 40, which I can see is shown by this longer line there. So that is 35 degrees, and I'm just going to mark it. Then I'm going to use a ruler to connect those lines, creating a 35 degree angle. On the original diagram, we can see that this side is a right angle. So to ensure that that's a perfect right angle, on my own triangle, I'm going to use the protractor again, and I'm going to measure 90 degrees to ensure that my right angle is perfect. Place my cross on the end of the line where I want my angle to be. Make sure the horizontal line on the protractor is exactly over the line I'm going to be using. And then I want to measure from 0 all the way to 90 degrees. I'm using the other side of the protractor this time, as that's the way that my angle is going to open. So starting at 0 all the way up to 90, and just make a line at 90. Then, just like the other side, I'm going to join my bottom corner here to the mark I just made, creating a 90 degree angle. Then these two lines need to be continued until they intersect. Question 14 states, complete the table. We can see in this table we've got 3 rows to the nearest 10,000, to the nearest 1000 and to the nearest 100, and we're going to round the number 39,476. So first we need to round it to the nearest 10,000. Well, if we think about counting up in 10,000s, we'd have 10,000, 20,000, 30,000, 40,000, and so on. If we look at the number that we're given, 39,476, well, I know that 39 is going to come in between 30,000 and 40,000. And thinking about the middle of this would be 35,000. So 39,000 is going to definitely be closer to 40,000. The other little thing to think about when you're rounding is if we're rounding to the nearest 10,000, which is this column, we want to look at the column directly next door to the right to help us decide whether to keep it the same or to round up to the next 10,000. And we can do that by 5 and above, that means we round up. If it's 4 or below, we round down. So thinking about the next one then, this time we're rounding to the nearest 1,000. So if we look at the 1000s column, if I was counting up in 1000s, 1,000, 2,000, 3,000, 39,476 is going to be in between 39,000 and 40,000. So if I'm rounding to the thousands column, I'm going to look at the column next door to help me decide. So does it stay as 39 or does it go up to 40? So it's a 4, so 4 and below, round down, so it's down to 39,000. It's closer to 39,000 than 40,000. Next, we're rounding to the nearest 100. So we're going to be thinking about counting up in hundreds, 100, 200, 300. So then we would get to 39,400, and the next one would be 39,500. So we're deciding whether it's closer to 39,400 or 39,500. So we're rounding to the nearest 100. So we're going to look next door at the tens column. We can see that it's a 7, so 5 and above, we round up. Just realised you can't see that. It's 5 and above, we round up, so it's not going to stay as 39,400, it's going to be going up to 39,500 as the closest. Question 15. Amina asked 60 children to choose their favourite flavour of jelly. These were her results. So in this table we can see the different flavours: raspberry, lemon, orange, blackcurrant, and we can see the number of children that voted for each flavour. What percentage of the 60 children chose orange? So as a fraction, it's going to be 15 children out of 60. So I'm going to start by thinking about it as a fraction. And then I want to simplify this fraction as much as I can. So I can see they're both in the 5 times table. So the first thing I'm going to do is simplify it by dividing the top and bottom number by 5. Dividing the numerator, the top number, by 5 will give me 3. And dividing the denominator by 5 will give me 12. I can see that both of these numbers are still in the 3 times table, so I can simplify the fraction now by dividing both the numerator and the denominator by 3. So 3 divided by 3 will give me 1 at the top, and 12 divided by 3 will give me 1/4. I know that 1/4 as a percentage is 25%, and that's a key fact that you should know. Question 16 asks us to write the missing number. 6 plus 2 multiplied by 2 subtract something equals 6. Now the first thing we need to be thinking about for this question is that we cannot just go through it from left to right. There is an order of operations, and that is known as BODMAS. So if there were brackets in this calculation, we would complete whatever was inside the brackets first. And then if there were any orders, so for example that means things like squared numbers, square roots, numbers with powers, indices. Next comes division, multiplication, addition and subtraction. So in this calculation here, we haven't got any brackets or orders or division. So the first step is to do the multiplication. So 2 multiplied by 2 gives us 4. Then comes the addition. So 6 plus 4. And that's going to give us 10. Then we can do the subtraction. So 10 take away something equals 6. So again, if we know our number bonds to 10, then we should know that 10 subtract 4 will give us 6. So the number in this box should be 4. Okay, question 17. We've got 2 shapes and they have the same perimeter, a regular hexagon and a square. The length of each side of the hexagon is 8 centimetres. Calculate the area of the square. So, first thing we can do is figure out the perimeter of the hexagon. So if we know that each side is 8, then to work out the perimeter, as it's a regular hexagon, that means all the sides are the same length. So we could do 8 multiplied by 6, which is the number of sides, because we've got 8 6 times. So 8 multiplied by 6, if we count in 8s, 8, 16, 24, 32, 40, 48. So 8 multiplied by 6 is 48. So that gives us a perimeter of 48 centimetres. The question states that the 2 shapes have the same perimeter. So we know that the perimeter of this square is also 48 centimetres. But the square has got 4 equal sides. So we can work out the length of one side by dividing 48 by 4. So 48 divided by 4, if you are confident with your multiplication and division facts, then you would know that that is 12. If not, you can still use the bus stop method. How many 4s in 4? 1. How many 4s in 8? 2. So that tells us that the sides of the square are 12 centimetres each. Now we know the length of each side, we can calculate the area of the square. So area of rectangles and squares are calculated by multiplying the base and the height. In this case, as it is a square, that is the same as 12 times 12, or 12 squared. 12 times 12, if we know our multiplication tables, is 144. This is a key one to know as it is 12 squared, so 144 is a square number. So the area of the square is 144 centimetres. Question 18 says circle the prime number, and then we've got 95, 89 and 87. Explain how you know that other numbers are not prime. So first of all, what is a prime number? So a prime number is a number that can only be divided exactly by itself or the number 1, meaning it's not in any times tables other than its own. So straight away, I can see that 95 will not be a prime number as it is divisible by 5. It is in the 5 times table, and I know that because it ends in a 5. And I can double check that down here just to be confident and show my working. So 5's into 9 went 1, with 4 remainder, 5's into 45 goes 9. So 5 multiplied by 19 gives us 95. So 95 is not a prime number. Then we're left with 89 and 87. Now, there are numbers in the 3 times table that end in 9 and numbers in the 3 times table that end in 7, such as 27. So I'm going to try dividing them both by 3 and see what happens. So 3 is into 89. 3 goes into 8 twice with a remainder of 2. 3 goes into 29 9 times with a remainder of 2. So 89 does not divide exactly by 3. I'm going to try 87. 3's into 8 go twice with a remainder of 2. 3's into 27 go 9 times. So it does divide exactly by 3. So 87 is not a prime number as it is in the 3 times table. So we've found our prime number. Circle the prime number, 89. Explain how you know that other numbers are not prime. So my explanation will be, I know 95 is not a prime number as it can be divided by 5. I know 87 is not a prime number as it can be divided exactly by 3. Question 19. A machine pours 250 millilitres of juice every 4 seconds. How many litres of juice does the machine pour every minute? So this is quite a complex problem. There are a few steps to this problem. So let's imagine it first. We've got this machine. It's pouring 250 millilitres of juice every 4 seconds. So if we think just about a number line to start with of time, and we've got every 4 seconds, so that's 8 seconds, 12 seconds, 16 seconds, 20 seconds, and so on, going up in 4s, and every 4 seconds we're adding 250 ml. So after the first 4 seconds, that's going to be 250. After another 4 seconds, that's going to be going up to 500. So that's to count in 25s. To count in 250s, we simply make the number sequence 10 times bigger. So then at 12 seconds, it would be 750. 16 seconds would be 1000, and so on. How many litres of juice does the machine pour every minute? So, first of all, we know that a minute has 60 seconds. So we want to see how many groups of 4 seconds go into 60. So I'm going to do 60 divided by 4. 4 goes into 6 once with a remainder of 2. 4 goes into 20 5 times. There are going to be 15 lots of 250 millilitres in a minute. So then we can multiply 15 by 250. So 250 multiplied by 15. So I've completed this calculation, 250 multiplied by 15, to show us that the 250 millilitres of juice is poured 15 times in a minute. So we want to work out how many millilitres altogether, and that came to 3,750 millilitres. We need to know that in litres. So 1,000 millilitres gives us 1 litre. So we've got 3,000 millilitres, so that will give us 3 litres. So we'd have 3 litres and 750 millilitres left over, but we need to give the whole thing in litres, so we've got to turn this into a decimal. 3.75 litres, and that's going to be our answer. Question 20. Tick the fractions that are equal to 20%. So first of all, I'm going to be thinking to myself that 20% is the same as 20 out of 100. Oops. 20 out of 100. And I can simplify this so that might give us one or two of the fractions that we've got there. So 20 out of 100, I'm going to simplify it so I notice straight away that they both can be divided by 10. So I'm going to divide my numerator and my denominator by 10 to simplify this fraction. So that gives me 2 tenths. I haven't got any there that are the same as 2 tenths, but I know some that it's not going to be. So 2 tenths can't be the same size as 2 hundredths, so it's definitely not going to be that one. I notice that 2 and 10 can both be divided by 2, so I'm going to do that, simplify it further. 2 divided by 2 gives me 1 as the numerator, and 10 divided by 2 gives me 5 as the denominator, so that's 1/5. I know there's definitely going to be more than one to tick because you get 2 marks for this question, so I know I need to keep looking. So 1/5, we can find an equivalent fraction by multiplying the top and bottom number. So let's have a look what I've got here. If I want to make the denominator 20, I'm going to have to multiply both numbers by 4. So 1/5, converting it into 20ths, times the top by 4 and times the bottom by 4. So that will give me a numerator of 4. So 4 20ths is not going to be the same as 1 20th. So we can have another look. So we've got 1/5 again. I want to see what happens when I make my denominator 40. So 1/5, I want that to become 40, so I'm going to have to multiply by 8. So I multiply my top by 8, that gives me 8 40ths, so that's not 20 40ths. One I've got left is 3 15ths. So 1/5, and I want to make it so that it's out of 15. So I'm going to have to do 5 multiplied by 3 this time. Multiply the top by 3, it's going to give me 3 15ths, which is the same as what we've got here. So that's the other one that we need to tick. Question 21. Adam has this rectangular piece of card. It is marked with grid lines. Adam makes 2 straight cuts along the grid lines. So that means his cuts can't go diagonally, they've got to go either horizontally or vertically along the grid lines, and he can only make 2 cuts. The 2 cuts divide the rectangle into 3 shapes, 2 squares of different sizes and 1 rectangle. So the special thing that we know about squares is that they are the same height and width. So the first thing I'm going to do is create a square, and this length of the rectangle is 1, 2, 3, 4, 5 squares. So if I go 5 squares across, that's going to create me a large square. Let's go 5 across and go along the grid lines, and let's draw where we're going to make the first cut. So here we've made 1 large square. So there's 2 squares of different sizes and a rectangle. So I've made a large square, so now I need to make a small square. Well, my square can't be any wider than 2 squares across, because that's the only shape that I've got left, as this has already made our first large square. So if I can only use 2 squares across, that means I can only use 2 squares down to make a square. So my next cut is going to be along the grid lines from there to there, and that makes me a smaller square. Then the third and final shape is a 3 by 2 rectangle, and we've only made 2 straight cuts. Question 22. This graph shows the maximum temperatures for 5 days. So we've got the temperature in degrees Celsius up the side of the graph on the y-axis, and the days of the week along the x-axis at the bottom. So we can see on Monday is 8.1 degrees, Tuesday 9.3, Wednesday 11.9, Thursday 11.8, and Friday 12.4. So it's gradually getting warmer. For what fraction of the 5 days was the maximum temperature below 10 degrees? What fraction of the 5 days? So our fraction is definitely going to be out of 5. And was the maximum temperature below 10 degrees? So this one's below 10 degrees. This one's below 10 degrees. So there's only 2. So my answer would be 2/5. What was the mean maximum temperature to 1 decimal place? So when we're finding the mean, we take all the values, add them together and find the total, and then divide by how many there are, and that gives us a mean average. So we're going to add together all of these values. We're going to use the working out box below. 12.4 and 11.8 and 11.9. It's important that you get your place value in the correct columns. Add 9.3. The decimal points are always underneath each other. Add finally 8.1. And then I'm going to total this up. So 9 add 1 straight away, that makes 10. Add 3 is 13. Add my 4 makes 17. And then to add on 8, 18, 19, 20, 21, 22, 23, 24, 25. Put my decimal point in. Add the ones column. 2, add 2 is 4. 4 add 9 is 13. Add 8 gives us 21. And add the 2 below to make 23. Then we add up our tens column, so we've got 3 there, 2 below, gives us 53.5 is the total of all the temperatures. The next step when we're finding the mean average is to then divide by how many values there were in the original question. So we're going to do 53.5 divided by 5, and for that we're going to use the bus stop method. So how many 5s in 5? 1. How many 5s in 3? There aren't any, so that 3 gets carried over. How many 5s in 35? Well, that's 7. Don't forget our decimal point. And it does say to 1 decimal place, so that's what I've got. So my answer is 10.7 degrees Celsius. And the final question of this test, number 23. Amina made this cuboid using centimetre cubes. So it's not to scale, but we know that the cubes in this shape are supposed to be 1 centimetre by 1 centimetre. It's 4 centimetres high, 6 centimetres long, and 3 centimetres deep. Stefan makes a cuboid that is 5 centimetres longer, 5 centimetres taller, and 5 centimetres wider than Amina's cuboid. So what is the difference between the number of cubes in Amina's and Stefan's cuboids? So if we're finding the number of cubes in the shape, that means we're really finding out the volume. And to find out the volume of a cuboid, we have to multiply the length, the width, and the height to find how many cubes would be inside. So to find the volume of a Mina's cuboid, we're going to do 4 times 6 times 3. So 4 times 6 gives us 24. Then we have to multiply that by 3. And for that, I'm going to use the column method of multiplication, although we could also do it mentally. 24 multiplied by 3. Start with the ones column. 4 times 3 is 12. 2 times 3 is 6. Plus the 1 is 7. So the volume of a Mina's cuboid is 72 centimetres cubed. To work out the volume of Stefan's cuboid, we need to first figure out what the dimensions are. So his cuboid is 5 centimetres longer. So 6 plus 5 makes his cuboid 11 centimetres long. So the first value that we're multiplying is 11. 5 centimetres taller, so 4 plus 5 makes his cuboid 9 centimetres tall, so we're going to multiply by 9. And his cuboid is 5 centimetres wider, so 3 add on 5 means his cuboid is 8 centimetres wide. So we're doing 11 multiplied by 9 multiplied by 8. So 11 times 9 is 99, and then we need to times that by 8. So again, I'm going to use the column method of multiplication. 99 times 8, or 8 times 9 is 72, carry the 7. 8 times 9 is 72, add the 7, makes 792 centimetres cubed. So that's the volume of Stefan's cuboid. The question asks what is the difference between the number of cubes in a Mina's and Stefan's cuboids. So to work out the difference, we then need to do a subtraction calculation. So we're going to do 792 take away 72. Make sure your columns line up. Start with your ones. 2 minus 2 is 0. 9 minus 7 is 2. And 7 left in the hundreds column. Stefan's cuboid is 720 cubes bigger than a Mina's cuboid. That was the last question. Thanks for watching. I hope this video has been useful to you. If you want to see any more SAT style walkthroughs, then please subscribe to my channel. If you've got any other ideas for how to answer some of these questions, leave me a comment below. If there's anything that you'd like me to do a walkthrough of in more detail, also let me know.